Hi guys, so let's review the mass on the inclined plane problem that we did today in class, just because this is something that you will need to know for the weekend. Okay, so here it is on page 10 of your packet. So a 5 kilogram block rests on a frictionless inclined plane tied by a string to the wall. The incline is at an angle of 37 degrees to the horizontal. Draw a free body diagram of the block. Okay, so in the free body diagram, we need to have our forces and our resolved components. So remember I said that you want to always orient your axes such that one of the axes points in the direction of this acceleration if the block was to move. So our potential acceleration is in the down the ramp direction. Okay, so our block would go like that. So I'm going to orient my axes such that it is this way. And just so I keep in mind which direction is positive and negative, I'm going to label this one as x. So here's negative x, and then y, and negative y. So I made up and to the right positive. Okay, so for our forces, I have the normal force on the block by the ramp, the tension force on the block by the string, and pointing to the center of the earth is the weight force. So weight force on the block by the earth. So on the free body diagram here, I would have normal force on the block by the ramp, tension force, and weight force. Now notice how the weight force isn't on the axes, and so I need to resolve this vector. And so the way that we did that in class was we said, well, if this angle down here is 37, then there's a right angle here. And because this is also a right angle, then this angle here is 53, which makes this angle right here 37. Okay, so this angle and this angle are the same. And so if I was to break apart my weight vector, then I'm going to have one component along the negative y-axis right here. And since that is the side adjacent to the 37-degree angle with the weight vector as the hypotenuse, then that side is w cosine 37 degrees. And then this side here is w sine 37 degrees. Okay, so when I come back to my free body diagram, I have one vector going down the ramp, which is w sine 37 degrees. Okay, so that is the horizontal component of weight, so that's also known as wx, the horizontal component. And then I have one vector down here that is the vertical component of weight, so that would be w cosine 37 degrees, or w in the y direction. So now that I've resolved my weight vector, I want to make sure I squiggle it out so that I know that it's not present any longer, that I've already resolved it. Okay, so now coming back to problem A, it says, what is the, problem B, what is the tension in the string? So since the tension occurs in the negative x direction, I want to do net force equals ma, or Newton's second law, in the x direction. So net force in the x equals mass times acceleration in the x. In the x direction, we have a positive w sine 37 degrees, a negative tension on the block by the string, and that's going to equal the mass times the acceleration in the x. But this quantity we know right here is 0. So I really have w sine 37 degrees minus tension is 0. Or tension equals w sine 37. W is equal to mg, so mg sine 37. And I'm okay with you guys using 10 for gravity. So 5 kilograms times 10 meters per second squared times sine of 37 degrees. Okay, so that's 50 sine 37. So that side should be 30. Okay, because that's the 3, 4, 5 triangle again.